My topic of presentation is geotechnical aspects for the foundation design. As the title of the faculty development program is on the civil and structural engineering, I decided to take this topic because for all the structures, the foundation design is must. For the foundation design, the civil engineers need to refer the geotechnical investigation reports. So what is being included in the geotechnical explorations, geotechnical investigation reports, bore log presentations, and how the bearing capacity computation has to be done for foundation design, it has to be discussed in this presentation. Whenever we are going for any geotechnical design, we need to satisfy some criteria. Whenever you are going for general foundation design and you are adopting the bearing capacity for the foundation, we are required to check the certain criteria. We need to say that in the foundation design, shear stress on the soil mass should not exceed the shear strength of the soil. The permissible limits given by the Indian Standard Code should not have to be exceeded for the foundation settlement. And as far as the soil strata is concerned, the liquefaction susceptibility has to be known to us. Based on the soil parameters at the different depth, we can come to know whether soil is susceptible to liquefaction or not. So these are the criteria has to be satisfied in the foundation design whenever you are going for any structure. You may be aware of the geotechnical investigations and geotechnical project sequence. As most of you civil engineers, you did the course of the geotechnical engineering. Many of you are faculty members. You know the significance of the geotechnical engineering and geotechnical exploration. You might be knowing that the geotechnical engineer needs to visit the site. They need to decide the experiments to be performed in the field. They need to decide the testing to be done on the laboratory based on the samples received from the field and correlate the data between the field investigations and the laboratory investigations. The common objectives of this geotechnical explorations are why we do go for the exploration and what is its need. To identify and describe the pertinent surface conditions, it has to be known to us. Determine the location and thickness of the soil and rock strata. It means that we are supposed to know what is the soil lying below the foundation level. Based on that, we need to calculate the bearing capacity as well as settlement. One has to be known to what is the groundwater table position. As the groundwater table position affects the bearing capacity and settlement, we need to know it. Recover the samples for laboratory testing from the site, conducting the suitable laboratory test, and identify the special problems and concerns. Means you need to know what is the type of the strata available at the different depth below the foundation. Does it problematic? Is it a weak deposit? If you do find such properties or such deposits, in such cases, the ground treatment or the ground improvement has to be required. Geotechnical investigation would consist of what? Whenever any of the civil engineer for his structure went to the geotechnical engineer and asked for the geotechnical report, what geotechnical consultant do? Geotechnical consultant decides the number of test bores to be done at the site based on the certain parameters. We will be going to discuss what are the parameters to be considered in deciding the number of test bores. We are also going to discuss what are the parameters to be considered in deciding the depth of the exploration. In addition to this, which soil test is required in which suitable soil conditions, field as well as laboratory testing, which we'll be discussing here in the today's lecture. And ultimately, once we get these things, we need to know the correlations between the field and laboratory testing. Hence, we can come to know about the detailed soil properties for the foundation design. Preliminaries, Brajayam Das in his textbook of Principles of Geotechnical Engineering has mentioned that how many borings and how deep you go for. As per the Brajayam Das suggestion, no hard and fast rule exists for determining the number of borings or the depth to which the borings are to be advanced. This indicates that Brajayam Das says that it depends on the geotechnical consultant who is working at the site. Based on the certain parameters, he or she may decide to go for the number of borings or the depth of the borings. However, there is a need to take the critical decision on numbers of borings as well as the depth of the borings. What are the factors which affects the decision of the number of borings as well as the depth of the exploration? How many borings you will go for the site? Conventional wisdom says that the number of boreholes will increase as the soil variability increases. As the loads increases, for more critical and significant structures, we have to go for the more number of borings. So these are the situations or conditions in which you have to increase the number of boreholes. Home rule says that in case of the soft soil, the spacing between the two boreholes required are 100 to 200 feet. Whereas in case of the harder strata, the spacing between the borehole increases and may go up to the 500 feet. This indicates that the number of borings required in the soft soil are more in compared to the number of bores required in the harder soil or the steep soil or the dense sand. How many borings you will go for? Structural project. Here two types of the project has been shown. One is the highway subgrade and second is the multi-story building. It has been found that in case of the uniform soil conditions, whenever lying below the foundation level or anticipated depth of the foundation level, number of boreholes required are less, and whenever you do have the irregular strata, the number of boreholes required are more because the spacing is being decreases. The similar things has been happen in case of the multi-story building too. However, whatever number of blows required in case of the multi-story building are very closer in compared to the boreholes required for the highway subgrades. In case of the multi-story building, it is suggested that you must have to go for minimum 5 bores. This slide is shown in terms of the area. For the different soil, for the one borehole, what area will be recommended. So in such cases also, high quality and uniform soils require less number of borings and poor quality and erratic surfaces required less number of borings, whereas high quality and uniform soils required less number of borings. Whatever Indian Standard Code suggests, as per IS 1892, clause 2.3.1, for a compact building site, covering an area of 0.4 hectares, that is approximately 4,000 meters square, one borehole or trial pit in each corner and one in center should be adequate. For smaller and less important buildings, even one borehole or trial pit in the center will suffice. This just indicates that whenever you do have the very important buildings, you are going for the rectangular plot area, having the size of the area is more than 4,000 meters square. In such cases, minimum number of boreholes required are 5 for the very important buildings. Whereas in case of the smaller buildings and ordinary buildings, when area is less than 4,000 meters square and plot size is square, in such cases, sometimes one borehole is sufficient. This has been happened because in case of the square plot area, the corners are closer to the centers and sometimes one borehole is sufficient. However, for every time one borehole is not sufficient, we need to decide on the various factors I discussed and we'll be discussing now also too. Since the soil is highly heterogeneous, some reference books suggest as under. In case of the heterogeneous soil, for the plan area of approximately 4,000 meters square or more, you have to go for the 5 bores. But in case of the heterogeneous soil conditions, in rectangular plot area, you must have to go for the 5 bores in 3,000 meters square area or closer to that area. Whereas in case of the heterogeneous soil, whenever you do have the square plot area is available, in such cases, instead of single borehole, we may have to go for the 3 number of boreholes. So the centers are closer, but we do not take any risk as the soil is highly heterogeneous. Hence, we have to go for the 3 instead of 1 bore. However, each and every time for the rectangular plot area of approximately 4,000 meters square, we need not to go for the 5 bores. Whenever you have to go for economy, whenever your buildings are ordinary, whenever you do have the very small project, in such cases, instead of 5 bores, sometimes 2 borehole works. So we may also go for the 2 boreholes in the certain conditions or the certain circumstances instead of going for the 5 boreholes. When area is to be investigated is large and plant layout is not finalized, the area may be divided into the grid of suitable size and test points taken on grid corners. Whenever you do have the irregular area, you need to put out it into the grid form. You select the important points and go for the boring exactly below that particular point. Where structural layout has been finalized, test points may be taken corresponding to with all important building units. Here, the important building units considered to be a staircase, heavy loading, heavy columns, heavy machineries. Wherever you are supposed to keep these things, you try to go for the boring exactly below that point. Hence, you can get this data particularly exactly below the important points. For various structures, the number of test points may be considered as here. Here, for the different types of the structures, how many number of boreholes you will have to go for has been mentioned. It has been suggested that in case of the multi-story building and apartments or multi-story commercial buildings, you must go for at least test the 5 boreholes. Whereas in case of the bridges, you must go for the exploration exactly below the each pier and abutment. However, for the lightweight utility structures, like parks, watchman cabins, you may not have to go sometimes for the boreholes. Even trial pit is sufficient. For the residential building or low-rise building, minimum 2 test bores are being recommended to perform. An additional test bore is required if required in certain conditions you may go for. This we have discussed about how will you decide the number of boreholes. How decision on the number of boreholes has to be taken by the geotechnical consultant. The civil engineer who are interested to go for their projects and meeting the geotechnical consultant, he may discuss also how many number of boreholes you will go for, what will be the depth of the exploration, what are the tests to be performed in the field, what are the tests to be performed in the laboratory. Accordingly, some meetings you can do with the geotechnical consultant to whom you are allotting the geotechnical investigation. This is important for all the civil engineers. As the case may be, in some cases, if you apply your knowledge, you can save your geotechnical investigation cost. If you do have some detailed knowledge, you can also save the construction cost too by recommending some of these suggestions to the geotechnical consultant. The depth of the test bores. The depth of the test bore should extend up to the point at which the vertical stress due to the proposed structure is equal to or less than 10% of the original effective stress at a point before the structure is constructed. This point is known as the maximum stress zone for the shallow foundations. Hence, we are going for the depth of the exploration about 1.5 to 2 times the width of the footing below the depth of the foundation. So we are considering this depth as a maximum stress zone for the shallow foundations. Hence, we can decide this depth of the exploration in our boring. However, certain points needs to be looked into in some of the projects while going for deciding the depth of the exploration. Here, some of the researchers have given that if you do have your number of story has been finalized and you do have your anticipated depth of the exploration for the different soil conditions, you can find out what is the depth of the borings you are required to keep. You may calculate on the basis of these equations for the different soils. It does indicates that in case of the good soils, number of borings required are less, whereas in case of the poor soils, number of borings required are more. How deep you will go for? Boring depth is governed by the various factors, including foundation type, foundation loads, covering, etc. Generally speaking, as far as the depth of the exploration in the bridges are concerned, is 50 feet to 80 feet is reasonable in case of the normal bridges. However, local experience is useful. If you are familiar with this particular site, in such cases, it may reduce your depth of the exploration. Look at the nearby structures if available. While visiting the site, you look into the nearby structures and you find that the structures are okay at present, which has been constructed in the past. It does indicates that there is no problematic soils, hence you can go accordingly or you can reduce the depth of the exploration in such circumstances, but not less than 1.5 times the width of the footing. If no experience or other information available for this your site, then you need to plan for first hole, and then we have to adjust. How many borings and how deep you will have to go for? This indicates that the final engineering can be no better than the data upon which it is based. Sometimes, some of the civil engineers are using the geotechnical investigation report of the nearby sites. and they take the bearing capacity and design the foundation. But it is not preferable to use the geotechnical investigation report of the nearby sites, as you should have your own data. You may be beneficial in both the ways. Geotechnical investigation report which you are referring, it will just give you the bearing capacity less than the bearing capacity of your site. In such cases, your construction cost will increase. The case in which if you are getting the bearing capacity of the soil more than the nearby sites, in such cases, you are beneficial. In the case, whenever you are getting the less bearing capacity than nearby site, in such cases, if you would have been used the data of the nearby sites, your risk has been increased because actual bearing capacity is lower than the nearby site. So in both the way, it is a disadvantage to us to use the report of the nearby site. Hence, you should have your own site reports, and accordingly, you need to design the foundations. The depth of the exploration at the start of the work may be decided as under. Some of the guidelines are given in IS 1892. In case of the isolated and draft foundation, the depth of the foundation is 1.5 times the width of the footing. In case of the pile and well foundation, this depth is 1.5 times the diameter of the pile below the depth of the pile. So these are the certain criteria has been given in IS 1892 to decide the depth of the explorations for the different structures. We have discussed till now what are the criteria to be designed, satisfied for the foundation design. What is being included in the geotechnical investigations? How do we decide the depth of the explorations? How do we decide the depth of the exploration? How do we decide the number of borings has been discussed. Now we are coming to some common field test. The most widely used method of subsurface investigation is boring holes in the ground and simultaneously conducting the standard penetration test and collecting the undisturbed samples. So, standard penetration test is very important for the foundation design, and most of the design of the foundations, conventional design of the foundation is based on the capital N value known as the standard penetration resistance. However, sometimes due to the site constraints, time constraints, importance of the project, erratic surface data, or to supplement the data obtained from the test bores, additional field tests are also required. This slide shows you what are the tests to be performed in the test bores. Here, the things has been mentioned with something about the standard penetration test, application of each test, information obtained from each test, and what precautions has to be taken in performing the test has been mentioned here in this slide. So, standard penetration test, undisturbed sampling, and in situ vent shear test, core in case of rock, pressure meter test, and permeability test. These are the tests to be performed in the test bores. Whenever we are going for the boring, we do go for the test bores, and this test can be simultaneously performed in the same test bore which has been mentioned in the column number 2 of the field test. Some of the things regarding some of the tests will be discussed here. What are the tests to be conducted in the trial pits? Generally in the field, we perform the test in the test bore or in the trial pits. So what are the field tests to be conducted? Are undisturbed sampling, plate load test, dynamic test. This IS 5249 is Indian Standard Code for performing the experiment of the block vibration test, cyclic plate load test. This test gives us the value of the coefficient of uniformity, coefficient of elastic uniform compression CU, and field CBR test, which gives us the value of the CBR for the pavement design. Plate load test is suitable in case of the homogeneous soil conditions. However, the plate load test is not preferable in the case of the non-homogeneous soil. In situ testing. What we do in the geotechnical investigation as far as the in situ testing is concerned, when it is difficult to obtain the undisturbed samples, particularly in case of the sensitive soil and in case of the cohesionless soil, it is not possible to obtain the undisturbed samples. Even if we get, we cannot rely on the results of the undisturbed samples collected from this. In such, we do have to go for the field test, or we have to rely on the field test. So what are the in situ test methods? In situ test methods are standard penetration test, static cone penetration test, and dynamic cone penetration test are the two cone penetration test and Venn shear test. So these are the tests generally we perform in the field and for the conventional foundation design. You may be aware of the standard penetration test. Standard penetration test is very familiar. I will come to you about the one sentence which has been written here as far as the standard penetration test or the N value is concerned. It has been mentioned in one of the slides by me in the presentation that 85 to 90% of the conventional foundation design is on the basis of the N value. Here, these are the specifications of the test. What is the weight of the hammer to be used? What is the height of the foil to be capped? For how much penetration it has to be applied, total 45 centimeter, and whatever number of blows required for the second and third part of the 15 centimeter presentation, summation of both is known as the capital N value, that is known as the standard penetration test. Now this value is very significant in the foundation design, which I am discussing to you in the today's lecture. However, there are some corrections to be applied to the N value. This is the speed put sampler, which has to be inserted while performing the standard penetration test. It has to be inserted in the borehole, and this helps us to get the sample from the borehole. This is the arrangement of performing the standard penetration test. So you may see that this is the hammer, this one is the height of the foil, this is the borehole in which the split spoon sampler has been penetrated. You are applying the penetration of 45 centimeter, whatever number for the sample, it is known as the capital N value, and significance of the N value we are going to discuss here in the next few slides. You may be aware of disturbed samples and undisturbed samples. Disturbed samples are particularly useful for finding out the grain size analysis and Atterberg limits. So particularly these samples we are using for the classification purpose, whereas the undisturbed sample is mainly used for compressibility parameters and the strength parameters. So undisturbed samples you need to be judged on the basis of the samplers which you are using. What is its area ratio? What is inside clearance, outside clearance? And you need to look into that, whether is it satisfying the criteria for undisturbed sampling, and hence you may consider the sample as an undisturbed sample. Here Here we are applying the dilatancy correction and overburden correction in the N value. N value is what? It should be noted that the standard penetration test is currently most popular and economical means to obtain the subsurface information, both on land and offshore. It is estimated that 85 to 90% of the conventional foundation design is made using the standard penetration test known as the N value. The N value has been used in correlation for unit weight gamma, relative density R. Sometimes it is also indicated as the density index ID or RD, angle of internal friction phi, and ambient compressive strength Q. So these are the parameters which can be correlated with the N value. Hence, we can come to know about the strength of the soil, and which can be useful in determining the bearing capacity of the soil. N value correlations. What are the correlations in case of the cohesionless soil and cohesion soil for the N value has been mentioned in this slide. The slides accommodate a lot of things as far as the geotechnical interpretation is concerned. Those who are familiar with these properties of the soil and N value and the correlations of the N value, they may do a lot of things in the foundation design using this tab. Here in the first column, the N value has been mentioned. The first part is consist of the cohesionless soil, where the soil is classified or described in the terms of loose sand, medium sand, dense sand, and very dense sand. In respect to this soil description and N value, the relative density of the soil and angle of internal friction has been mentioned. Those who have been studied the bearing capacity of the soil in detail, they may have some idea about the general shear failure and local shear failure. The soil in which the general shear failure occur, it is a good soil. That may be a dense sand or the very steep clay. So angle of shearing resistance in such cases is about 36 degrees. Whereas in case of the local shear failure, the angle of shearing resistance is less than 28 degrees. The relative density is being correlated with the N value and angle of internal friction phi. Relative density describes the quality of the sand or quality of the cohesionless soil. The good value of the relative density above 65 indicates that the soil is a dense sand. In such circumstances, soil is having the relative density above 65%. The chances for the soil to be liquefied are minimum. The liquefaction chances are not there, or may not be susceptible to the liquefaction when soil comes under this category. Whereas soil is considered to be a loose sand, in such cases the chances of the liquefaction are minimum. So angle of internal friction is being used for determining the bearing capacity. It has to be used for finding out the bearing capacity factors. In the various methods, the various tables or charts are available to find out the bearing capacity factors such as NC, NQ, and N gamma based on the phi value. So this table indicates, left part of this table indicates the cohesionless soil interpretation for the N value. Whereas in case of the cohesive soil, for the different N value, the soil description has been mentioned here. The soils are classified as very soft, firm, steep, very steep, and hard. Unconfined compressive strength of the subsoil or range of such values has been mentioned based on the N value. But whenever you are using the N value for the interpretation of the foundation design, you cannot use only N value, but simultaneously we need to have what is the soil type, why it is necessary. Just I am telling you, in case of the soil having cohesion less, N value is 10, soil is classified as a loose sand. Here, this soil may have the bearing capacity less than 100 kilonewton per meter square or 10 ton per meter square. Whereas in the case when N value is 10 and soil is classified as a steep clay, the UCS value, that is unconfined compressive strength, is 1 to 2. In such cases, though your C value is having the good value, and hence the bearing capacity value of such soil having N value 10 in case of the cohesive soil may go up to 250 kilonewton. Hence, it is needed to have the soil types with the N value. Use of the SPT data we are doing for knowing the relative density, angle of shearing resistance, and cohesion. These are the this is the cone which is being used for performing the static cone penetration test, where we determining the tip resistance or the end bearing and frictional resistance. These are the truck mounted operations of penetration test has been shown here. What we do measure using the cone penetration test are the cone resistance and sleeve resistance. Cone resistance is QC and sleeve resistance is FSC. So here you do have the frictional resistance. Here you do have the cone resistance. It has to be used in the data. It has to be shown in this form. This is knowing the side friction or the frictional resistance. This is penetration resistance. However, in case of the static cone penetration test, it does not give a soil sample. Hence, we are required to go for the bore log simultaneously. We need to know the soil types, and accordingly we can interpret the results. Now, what is the soil types? Based on the cone bearing and frictional ratio, it can be obtained from this chart. This chart is useful to know the soil types based on the results available from the cone penetration test data. What is the Van shear test and what we are doing with that? The soil, whenever it shows a great difference in the strength measurement, in case of the undisturbed sampling and remodeled sampling, that soil is known as soil. Whenever in such soils, we are measuring the strength in the undisturbed conditions and remolded conditions, this ratio is coming more than 4. Such soil is known as the sensitive soil. This test is a quick test known as the Van shear test to perform on the soil samples. It is not preferable to perform the test in the laboratory as far as the strength parameters are concerned, as there is a highly disturbance in collection of the samples. So we do have the Van shear test. The test is to be performed in the borehole of the required diameter. This van is to be inserted into the borehole. Diameter of the van is to be measured. Height of the van is to be measured. This has to be inserted and rotated inside the borehole. The torque at which the soil fails, it is noted. Based on the torque value, based on the height of the van and diameter of the van, we can determine the shear parameters of such soil. Hence, we can obtain the bearing capacity of the soil. You may compare the different tests in this point in terms of the simplicity, easiness of the testing, resolutions, basis for interpretation, types of soils, equipment's availability, and potential for future development. These points you need to keep in the mind, and accordingly you may decide the field testing, which field test you will go for, and which one is beneficial to you. Accordingly, you can take the decisions based on these points which has been mentioned here. Groundwater monitoring is being needed at the site as it affects the bearing capacity and settlement, which has to be measured using the piezometer. This is the equipment for SPT test. What are the advantages over SPT of CPT test has been mentioned here. Provides the much better resolution and reliability, versatility, pore pressure measurement and dynamic soil pressure measurement, dynamic soil properties measurement are important in case of the CPT test. Whereas the disadvantages of the CPT are that does not give a sample as discussed. You need to go for the simultaneous boring, will not work with the soil with gravel, and need to mobilize a special rig. Heavy equipments and machinery is being required in performing the CPT test, but mostly it is being recommended to perform whenever you have to go for the deep foundations to rub. Field CBR test is the another test which we perform in the design of the pavement. Why the field CBR test is to be performed? So guide parameter for design of the flexible pavement, evaluate the strength of the subgrade and base, this for roads and runway pavements. For these reasons, we are performing the CBR test in the field. It is also possible to perform the CBR test in the laboratory, and we do go with that. This is the arrangements of the CBR test. You may have worked a lot on the plate load test. You might have seen the plate load test at the various sites. As you know that the size of the plate is being used in performing the plate load test is 1/5 of the size of the foundation. So whatever pressure bump you are going to get for the plate is of the smaller depth, whereas the actual pressure bump depth of the foundation is larger one. So if soil strata is similar, the results work for the design. If your soil strata is not similar or homogeneous, in such cases, the plate load test is not recommended to take it for the bearing capacity and the settlement computation. These are the arrangements for the plate load test. This we can discuss about what we are doing in the field whenever you have to go for the geotechnical investigation. What we do basic things in the geotechnical investigation. V.N.S. Murthy in his notebook, in his textbook, has mentioned that you need to balance the cost and risk. The scope of a subsurface exploration for any particular site is a difficult problem which is closely linked with the relative cost of investigation and the project for which it is undertaken. This thus indicates that as far as the soil investigation is concerned, you may not spend too much for the ordinary buildings or low-rise buildings or unimportant buildings. Whereas, wherever the more risk has been involved, whenever you are going for the prestigious projects, whenever you are going for the heavy structures, whenever you are working on the poor soils, in such cases, you cannot take a risk to save the money, but you have to go for the detailed investigations in such circumstances. Means you need to manage your cost and risk as far as the geotechnical investigation is concerned. Whatever we have been discussed, it is what we are doing in the field and starting the geotechnical project. Now we are coming to the laboratory. What we do in the laboratory? What are the tests to be conducted? And what test is important for what or which data is being used for the foundation design after conducting the test? So here we do have, you are familiar with all these things which has been mentioned on the right hand side. Moisture content, unit weight, sieve analysis, utterwork limits, compaction, hydraulic conductivity, consolidation, direct shear, triaxial shear, unconfined compression. So these are the laboratory testing which we are doing on the soil while we are getting the samples in the laboratory. But for all soil test may not be required. We need to take the decisions on the basis of the types of the soils, and accordingly, we need to decide the performance of the testing. Whenever you are studying the three-phase system of the soil or the two-phase system of the soil, in the topic of the weight-volume relationship, you may have been known that you need to get the various soil densities or unit weights. You need to know the unit weight of the soil solids, bulk unit weight of the soil, dry unit weight of the soil, saturated unit weight of the soil, submerged unit weight of the soil. You need to know the void ratio, porosity, degree of saturation, water void ratio. Many things need to be known as far as the weight volume relationships are concerned. This is being used for the pressure computation, for computation of the volume of solids and other parameters. You might have worked with the interrelationship between these properties. And if you are knowing some of the properties, other properties can be obtained based on the data available. This slide is very, very important as far as the fine grained soil is concerned. You are aware of the various limits known as the Atterberg limits, liquid limit, plastic limits, shrinkage limit. Then soil indices, plasticity index, liquidity index, consistency index, flow index, toughness index, activity number. These are all important in case of the fine grained soils. Whenever we are working on the fine grained soil, we need to know the soil properties for Atterberg limits and grain size analysis for the soil classification purpose. Many of you may be knowing how to classify the soil in the detail as far as the coarse grain classification soil is concerned and fine grain classification soil is concerned. Soil indices are very, very important to know the degree of firmness of the fine grain soils. Shrinkage limit is important in knowing the expansiveness of the soil. Activity number is important in knowing the expansiveness of the soil. So all these things are being required. Gradation characteristics, such as you are drawing the particle size distribution curve of grain size versus percentage of particle, and based on that, we are getting the various diameters: D10, D30, D60, D15, D50, likewise D85, all these things. This data is being required in the filter design of the dam, as well as it is also required to classify the soil. Either our soil is well-graded soil or poorly graded soil. It can be classified on the basis of uniformity coefficient and coefficient of the curvature. U is equal to D60 upon D10 and CC is equal to D30 square upon D10 into D60. Consolidation characteristics are important in case of the saturated clays. So in case of the saturated clay, the consolidation test is to be performed in the laboratory. We need to find out the parameters which has been mentioned here: coefficient of the volume change, compression index, recompression index, etc. Coefficient of the volume change is used for finding out the consolidation settlement, as SC is equal to MV delta sigma H. Particularly useful in case of the over-consolidated soil, whereas compression index is used for the normally consolidated soil to find out the consolidation settlement. The equation which we are using is HCC upon 1 plus E0, log 10 sigma 0 plus delta sigma upon sigma 0. Mentioned in the RWDA book, the combination of the compression index and recompression index is being used for finding out the magnitude of the settlement in case of the over-consolidated soil. This way, you are familiar with the various methods to find out the coefficient of the consolidation in the laboratory, known as the log-t method and square root time fitting method. This is being used for determination of the coefficient of the consolidation, and by this, we may get what is the time required for the consolidation. It can be determined on the basis of CV. Strength characteristics we have been discussed in the one on another form in the previous part of the lecture. Coherency, angle of shearing resistance, unconfined compressive strength, and bearing capacity factors, SPD flow count, sensitivity. These all things comes under the strength characteristics. NC, NQ, and N gamma is to be determined from phi value. N value is the standard penetration test. Sensitivity of the soil is estimating the effect of the disturbance of the structure on the strength. Compaction characteristics are very, very important in case of the earthworks. Whenever, yes. Anything else?
Yeah, sir. Yeah.
Yes, what?
Yesterday, I got call from the BTech students in 30 days.
Hello. Please.
What problem can arrange slips?
What happened? Hello.
Are idiots? If you put slip, you will fail. Mid exams, you did like that only. Come down to the college. I'll explain you. I'll give you guarantee. But those two weekend students are very. If Professor sees us, no, he'll be shocked that we are learning.
Hello. Somebody is speaking, I think. Can you mute your mic? Hello. Hello. Somebody is speaking. Can
Sir, please unmute.
Sir, we can't hear your voice.
Yes. Solanki, sir. Phone karo.
okay. Carry through. Hello. Hello.
Sir. Yes, sir. Yes, sir.
Yes. Okay.
Sir, before 2 slides.
Okay. Okay. Fine. I will. Okay. This one is okay. These are the preliminary slides. Are they audible now?
Yes, sir. Yes, sir. Perfect.
Okay.
Sir, just do slideshow.
Okay. I'm doing it. So we do have the swelling parameters, free swell index and swelling pressure test, which we have to be determined in case of the expansive soils. SPC based on the shear failure. General shear failure, we do have the bearing capacity equation. In the local shear failure, we are using the dash parameters. We reduce the C and phi parameters by 2/3 in case of the local shear failure. Many of you may be familiar with these equations given in IS 6403. Similar to the Terzaghi's equation of the bearing capacity, we do have the determination of the shape factor, depth factor, and inclination of the load factors. We do have the position of the water table effects to be considered in the equation of the bearing capacity. Whenever we are getting these results from the field as well as laboratory, we put it in the form of the borehole. The first part of the borehole, which has been presented here, it is showing what is the depth of the foundation, what is the depth of the exploration, what is the visual inspection, what is the soil types. On the basis of the laboratory testing, what is the position of the water table, which field test has been conducted, disturbed sample, undisturbed sample, standard penetration test, what are the end values at the different depth. It has been mentioned here in this slide. In the next part, it is continued with the laboratory testing results. These laboratory test results are grain size analysis, Atterberg limits, IS classification. Then we do have specific gravity, shear parameters, consolidation test, and swelling characteristics. After analyzing all these results, we do calculate at the different depth and for the different size of foundations, the shape bearing capacity of the soil. So shape bearing capacity is being computed using the data as per the IS 6403. And here they have been discussed. How do you find out the shape bearing capacity? Shape bearing capacity is one in which the shear criterion is being satisfied. But what to do for the settlement criteria? In foundation design, we will have to take the allowable bearing pressure, total load on the column, divided by the allowable bearing capacity is giving you the size of the foundation required or the area of the foundation required. Before that, from whatever we have been discussed, I have been written in the form of conclusion. Now I will take your 10 to 12 minutes to explain you how do we determine the allowable bearing pressure, how the settlement of the computation of the settlement can be done on the basis of the various soil parameters. This problem is being taken from the book of the Satyendra Mittal. The title of the book is Soil Testing for Engineers. Industrial building in the central India has to be located. It is a 3-story structure. Type of foundation is raft. Size of the foundation is 12 meter by 7.5 meter and depth is 1.5 meter. We are going to calculate how the total settlement of the foundation is being computed. And based on that, how do we determine the allowable bearing pressure? This is the bore log detail given. This bore log detail indicates what is the soil types. It indicates the depth up to which the exploration has been made. It indicates what are the samples collected, undisturbed samples. These are the values of the SPT test has been mentioned here. And corrected value has been written here. What is the position of the groundwater table? As explained to you, we are required to go for the minimum depth of the exploration, equivalent to 1.5 times the width of the footing. So 1.5 times the width of the footing is 1.5 into 7.5, that is 11.25 meter below the foundation level. The value of the C and phi at the different depths are also given. So this is the data given in the bore log form as far as the soil investigation is concerned for the given problem to get the allowable bearing pressure. Now influence zone has been discussed to you. Position of the water table. This is the strata below the foundation level. The values of given are C is equal to 3 ton per meter square, phi is equal to 8 degree. G is 2.65, water content is 8.75, and compressor index is given 0.11. Other parameters are being computed from the data given, such as the bulk density and void ratio. Void ratio has been found out as 0.656. As far as this presentation is concerned, the void ratio is having significance in classifying the soil as a general shear failure or the local shear failure as far as the IS codes are concerned. The value of the bearing capacity factors are to be taken from the 5 values using this chart. However, our case is not of the local shear failure or general shear failure. We need to interpolate the results. Interpolation of the results will be required in computing the bearing capacity factors, which will be shown to you here in this computation part. It has been mentioned that whenever the void ratio is less than 0.55, the soil is considered to be a dense sand, and probable method of analysis is general shear failure. Whereas it is greater than 0.75, the soil is considered to be a loose sand, and you do have to go for the local shear failure. However, in our case, the void ratio value is between the 0.55 to 0.75. This is 0.656 is in our case, hence the method of analysis is interpolated. This is how do we determine the shape factors for solution of the problem, depending on the width and length of the foundation and shape of the foundations. You do have the NC value is 5.4 in such circumstances when phi is 0. Here you do have the depth factors, inclination of the load factors. Our load is straight and vertical, no need to imply. Our high value is 8 degree. When it is being reduced by 2/3, it comes to 5.4 degree. The value of NC, NQ, and N gamma are interpolated here, and these values are being found here. So interpolated values of the bearing capacity has been computed and been taken into the analysis for determining the shape bearing capacity. It has been taken. Factor of safety is taken as 2.5. These equations are being used and shape bearing capacity is being computed. Now you see that finding out the shape bearing capacity may be knowing by you how to get it. The various textbooks describe the problems on determining the shape bearing capacity. So you do not have a major problem in determining the shape bearing capacity. But what we are going to discuss here is how to find out the allowable bearing pressure. Allowable bearing pressure is 1. It is the net loading intensity at which soil neither fails in shear nor there is an excessive settlement detrimental to the structure. So we need to find out the total settlement. We have to check it with the permissible limits given by the IS codes. We need to look, and what has to be done next, it has to be discussed here. The settlement part of the foundation is consist of the stress distribution. You may apply any of the method, either Boussinesq method, Newmark's chart, or influence factor. Influence factor is being used in our problem, where N is equal to L by B and M is equal to 2Z by B. Where Z is considered to be, it is the center of the clay stratum from the foundation level. We do have the existing overburden pressure line here for the given problem. There are 6 layers lying below the foundations, below the 1.5 meter depth, below the ground level. You can see that there are 6 layers. Out of the 6 layers, 5 layers are of the CL sand, and 1 layer is of the silty sand. So in such circumstances, in case of the clay soil, we will have to compute the consolidation settlement. In case of the silty sand, we are required to compute the settlement based on the N value. As the compression index CC cannot be used for finding out the settlement of the sandy soil, we need to use the capital N value. So here M is equal to 2Z by B and N is equal to L by B. Z is the depth of the center of the particular trace datum. It has been taken here 0.5. Height is 0.5. The first layer is of 1 meter. Its center is at 0.5 meter from the bottom of the foundation. That's why it is 0.5. Similar things for the second layer, it is 1 plus 2 by 2, that is 2 meter. Z is equal to 2 meter for the second layer. Z is equal to 4 meter for the third layer. Z is equal to what you may compute for the fifth layer and sixth layer. For the fourth layer, we have to use the capital N value, that is the standard penetration test, to find out the settlement of the foundations. So here we have influence factor has been obtained from the chart is 0.991. So what is the incremental stress for the first layer delta P1, which has to be used for computation of the consolidation settlement? It is being computed as 10.14 into 0.991. This value is coming out to be 10.05 ton per meter square. The incremental stress for the layer 1 is found out to be 10.05 ton per meter square. For the 2, it is found out as 9.49 ton per meter square. For the third layer, the settlement which has been computed using this equation has been found out for the first layer is 41 mm. For the second layer is 57.3 mm. And for the third layer is 36.1 mm. Whereas in case of this sandy strata, where it is a silty sand and corrected is being used, average N value has been 18.80. But Indian standard code suggests that if you are averaging the N values and any of the N value is 1.5 times more than the average value, you discard that value and you compute the average value once again. As the value of 29 is more than 1.5 times of 18, this value has been discarded. And N is computed again. The N value has been found 15. Width of the foundation is found out as 7.5 meter. The soil is under the submerged condition as far as the SM layer is concerned. And hence, we do have computed the settlement of the same layers too. While calculating the settlement, this is the effect of the water table in bearing capacity. This is how to compute the settlement while knowing the N value and width of the footing given in the IS 8009 Part 1. This is how do you find out the depth factor and rigidity factor in computation of the magnitude of the settlement has been mentioned here. So total settlement of the foundation is computed as 160 mm. May I audible? Hello?
Yes,
Hello?
sir.
Yes, sir.
You are audible.
Applying rigidity factor and depth factors, the settlement is coming out to be 123
Yes,
mm. Yes, okay. The total settlement is coming out to be 123 mm. This thus indicates that in case of the rough foundation, the allowable settlement is 100 mm. But for our side, we have been settlement of 123 mm. So this settlement is, this bearing capacity is reduced for additional 23 mm. Hence, the bearing capacity of such soil has been found out as 8.2 ton per meter square. This is known as the allowable bearing pressure. So in the today's lecture, I wanted to discuss to you about the soil investigation, field parameters, laboratory parameters, borehole chart, determination of the allowable bearing pressure, and significance of the soil properties, which I did here in the today's lecture. I thank you organizers for inviting me to deliver the lecture. Also thanks to all participants for your interest in attending this lecture. Thank you all.
Thank you, Solanki sir, for